we are given that the distance that a bicycle travels in 1 minute varies directly as the number of revolutions. And the bicycle travels a distance of 450 feet when the wheel turns at an RPM of 60. And given this situation, we have to determine the distance traveled by the bicycle in 1 minute when the wheel turns at an RPM of 87. So let's see how to determine this distance. First, I'm going to write down this direct variation equation. That is, let me represent d, that is the distance traveled by the wheel or the bicycle. I write down this as d, and this is directly proportional to the RPM. I'm going to write down this revolutions per minute as R sub p. So I'm using this letter or the variable R sub p, which represents the RPM. So here we see that the distance is directly proportional to the revolutions per minute. And we can rewrite this direct variation equation by introducing a constant of proportionality. So we write this as d equals k times of R sub p. This RP represents the RPM of the wheel. Now let's use the first information. That is, when RPM equals 60, the distance traveled is 440. So we have to plug in D equal to 440 and the R sub P, which is the RPM, equals 60. And we'll do that and we can determine the value of the constant K. So I plug in D equal to 440 and this equals K times of R sub P, which is 60. So this gives 440 equals 60k. Now we can determine k from this. I write k, and this equals 440 divided by 60. We can cancel these zeros immediately, and this reduces to the fraction 44 over 6, and this can be reduced as 22 over 3 because this is 22 times of 2 is 44 and this is 3 times of 2 is 6. So we cancel this common term which is 2 and so it reduces to 22 over 3. So we have determined the value of k equals 22 over 3, which means we can plug it into the is variation equation, that is into this equation. So let me do that. That is the relation between the distance as well as the RPM. So we get d equals, I replace k by 22 over 3, and this is times of the RPM, which is written as R sub p. Now we have to determine the distance or the distance traveled by the bicycle in 1 minute when RPM is 87. So plug in R sub p, which is RPM, and this equals 87 into our distance versus RPM equation, and we can determine distance. So therefore we write down d equals 22 over 3 times of R sub b is 87. We do this cancellation, this goes 29 times, and then we multiply this 22 with the 29, which is equal to 638. So therefore, we see that the distance is 638 and the unit is feet. Therefore, the bicycle travels a distance of d, which is 638 feet.